Hey there. Welcome back, brother. All right, my friend. Let's see what kind of questions you came across on that homework that was supposed to be due today or yesterday that we made due today. What can I help you with? Because we do have that quiz tomorrow, right?
Yes, 7B.
7B?
Yes.
What fasting blood glucose level is at the 95th percentile? Okay, so what's funny is I actually was thinking about this question. So 95th percent, so this is 7B, versus 95th percentile. For right now, let's say that they are the same thing. So that means that we're dealing with the area under the curve. So you're talking about, 95%. So basically, they're looking for what is this score that would make us have 95% of our area. Okay? So then I'm going to go to our friend, the calculator.
But hold on, so for number 3 talks
Three.
about fasting blood glucose level, and it says it's anything between 100 and 125.
Okay, so the 100 and 125 is like 100, 125. So you want to find what the area is.
Yeah. So.
But then the 95th percentile would be, I'm talking about we are doing better than 95% of everybody else.
So do you?
So what z-score would this actually be? So that's kind of what you're looking at with that. So you're going to do your, so I'll go back to 3 as well, and we'll show how we can do both. All right, so, oops, I want this. All right, so I'm going to go inverse norm. So second, where'd it go? Let's just go second enter. Inverse norm, 95th percentile. So 95th is 0.95. Oh, clear. I gotta get rid of that. All right, so inverse norm number 3. 95th percentile is 0.95.
Mm-hmm.
Okay. They told us. Recall the.
Oh, the mean is 84.
84. Okay.
And the standard deviation is 8.
Okay. Oh, that's from above.
Yeah, for the regular.
Yep. So we're looking for the area to. We're talking about the area to the left. So what we're doing is color in 95% of our area under the curve. That's what the 0.95 is. Where does that land on the x-axis? So if I paste it, and it says boom. So if you had a 97.16 z-score, meaning on this thing, it would give us 95% of the information to the left. The area to the left is 95%.
Okay, so then it doesn't matter that it's a fasting blood glucose level. It doesn't matter that it's between 100 and 125.
Right.
Okay.
Yeah. Okay, and then
Use 7A.
7A.
Yeah.
What is the z-score of the 95th percentile? Okay. So z-score, we're going to go, what did we say? So,
Then wouldn't those answers end up being the same?
So I'm going to put the 97.15 in. And then what was our average? 84 over standard deviation 8. So whatever that comes out to would be our z-score, which would be, I don't know, 97.15 minus 84. Divided by 8. So you are 1.7 standard deviations above the mean, rounded to 1 decimal. Okay, and then you said number 3, is that the?
Well, that's the one about fasting. The fasting, but I think we did that one yesterday.
Oh, okay, cool. Anything else that I can help you with? The quiz tomorrow, I think, is really pretty easy. The main thing too, and I'm not saying that because I'm the teacher. When I actually did it, it was like I didn't have to put a lot of thought into it. So just think about if you're talking about 95% or some percent, you're doing the inverse normal, okay? Because this is talking about an area where area is 100%, okay? So that's what we're talking about. You know, that obviously the z-score, you have the observed minus the average or the mean over the standard deviation. So those are all things. The z-score tells you where do you fall on the x-axis. The percent is how much area we're talking about between the two. Good enough? All right. So I want to go through 97, which is pretty quick, which will build upon for what we need for the quiz on 3.1 to 3.5. So this is pretty simple. This is 3.7. I'm on page 74 of the notes. Okay, so let's say, and this is not on our notes necessarily, you can squeeze this in. This is our mean. This is our standard deviation. So let's pick on CP Algebra 1 because they're easy to pick on. Let's say I give the quiz that I give them today, and I realize the average score is a 45%. Now, and friends, all of your teachers should think this way, okay? And if they don't, shame on them. If I give a test and I feel that I taught really well about it and I have a relatively good class and I pull out a 45% average, I need to go back and think about what the heck that test was actually asking. And then I have to realize, you know what? I forgot to teach these three key pieces. So kids did pretty cruddy on it. So I can either go back and try and teach those three pieces again and re-quiz them. And I don't have a problem with re-quizzing, but it's better if I go and I reteach and I put that content on the next. And then what I'll do is I'm going to change this. I'm going to hit this with a different scale factor. Okay, so let's say right now my mean was 45%. And let's say the standard deviation, just to make it simple, was 5%. So then we have 50% grades, 55%, 60%, 40, 35, and 30. Now, if I decide, you know what, we want that to be the 70%. Okay? So what I have to do is I'd have to multiply 45 times some number to get to 70. Okay? And then what I could do is I could say, well, I'm going to multiply everything by 70 over 45. And 70 over 45, my calculator will come up. 70 divided by 45 comes out to 1.6, rounded to one decimal. So if I were to multiply this by the 1.7, it doesn't change my spread, it just changes the scores because everything gets multiplied by the same thing. So the spread, it doesn't go and incorporate that the kid who got a 30 that was below 3 standard deviations below the average, that student still is going to fall 3 standard deviations below the average if I multiplied everything by a scale factor. Okay? So a lot of times we have different, if y'all took chemistry, it's a little maddening to you. It was maddening to me, and I have a minor in chemistry. We have 3 different ways to measure temperature, basically. You have the Kelvin scale based on absolute zero. You have Celsius or centigrade, depending upon where in the United States or the world you're talking about. And then you have Fahrenheit. And I would bet you more than one of you has thought, oh, it's talking about 36 degrees, and you see the letter C there, but you decide that it's supposed to be the letter F. 36 degrees Fahrenheit is different than 36 degrees Celsius, right? It's not, but if I found, so the boiling point of water is 212 degrees Fahrenheit, 100 degrees Celsius. Okay, so if you measured something with a Fahrenheit thermometer that water that was boiling with a Fahrenheit, you get 212. If you measure with the Celsius thermometer, it gives you 100. So 100 Celsius is the exact same thing as the 212. It doesn't change the factor of it. Okay, and I'm sure you've seen the conversion. Fahrenheit equals 1.8 C times 32. So um, whatever your Celsius temperature is, you'd plug in and you could modify. Of course, you could work the other way too. If you had a Fahrenheit temperature, you could just solve that for C. And I know that in chemistry they give you 5/9 versus 9/5, which is the, 9/5 is the 1.8, 5/9 is not 1.8, it's a different fraction. But those are a few things. So they talk about on page 75, says, let's consider the grade adjustments of a science class. Teacher might give an exam, which the mean is 66, standard deviation 8. So this is going to go along kind of what I was talking about. The nice thing is my grade program does it for me. It tells me what we did. The teacher might decide the test was tough and the grades need to be adjusted. Some of the possibilities are outlines below. Bless you. Option 1, the teacher might decide to add 9 points. So if the teacher decides to add 9 points to everyone, this would create a new mean of 75, but leave the standard deviation unchanged. Okay, so what this means is if that person's their new mean is going to be 66 plus 9, so that's going to give me 75, but we're still going to have a standard deviation of 8 to keep our spread consistent. So if you add points, you're not adjusting what the standard deviation is. Now, of course, if I were to write this on a normal curve, the standard deviation would become, if I want 8 out, I could find one standard deviation out by adding. So I'd have one standard deviation out being 83. Okay? Whereas the standard deviation on this one, if I added those together, that's going to give me 72. Okay? So the spread of the data is still going to be the same. Yes, this is improved, but your standard deviation is still going to be 8. It's not going to become some new magical number. Option 2, the teacher might decide that to double everyone's score, that would produce a new mean of 132 and a standard deviation of 16. So option B, because I multiplied, I doubled. That means that the mean and the standard deviation are both times 2. Okay? Multiplication is a higher order operation than addition is. Okay? It's not necessarily changing your normal curve, it's just giving you an elevated score amount. The teacher might decide to double everyone's score, then subtract 50. This will produce a new mean of 82. So if you double everyone's score, and then added 50, but then the standard deviation is 16. So I double the standard deviation of 8, but because I subtracted a number, I'm not going to subtract from the standard deviation as well. It still has that type of spread. Okay, so those are just a few things to talk about. So multiplication, so a scale factor that's multiplied changes the mean and the standard deviation by the same scale factor. If I double everyone's score, the mean and standard deviation are both double. If I tripled everyone's score, that's going to happen. If I add to the scale, so I just decided I'm just going to bump points in, my mean gets added to whatever I add, but my standard deviation stays the same. And then the last characteristic that I talked about is, what if I multiply and then add or subtract? Then your mean will have the multiplication and the add or subtract factor, but your standard deviation will only be multiplied. Okay, does that make sense? So multiplication changes both the mean and standard deviation. The addition or subtraction will change the mean It doesn't change what the standard deviation would be to keep your spread the same. The main reason why multiplication changes something versus addition or subtraction doesn't change the standard deviation. If you add or subtract, you're counting up or you're counting down. When you multiply, you're actually theoretically changing the dimension that you're working in. Okay? So if you multiply three numbers together, theoretically you're in the third dimension. If you wanted to find the volume of like a cube or some sort of shoebox, you'd say, well, it's 12 inches this way, 6 inches this way, 8 inches tall. You multiply those numbers together and you get the volume. If you went to fourth dimension, which does exist, or there's multiple dimensions exist, you actually have infinite dimensions. We have 7 dimensions that are classified that we know of as far as length, width, height. Time is a half dimension. It's a half dimension until you can figure out how to go back in time. But there's other things that happen at the subatomic level that are not explainable by normal length, width, height, and time, that they have other dimensions that link with. So that's kind of way goofy math theory. We're getting kind of crazy on stuff. Okay, so what I would like to have, let's see, today is Wednesday, so we have a shorter period. I realize that. Why don't we, I don't need to do that. We're skipping the review. We're actually going to go to page 199 and 200. And this will be due on Friday. And we have a quiz tomorrow on 3-1 to 3-5. Okay. So again, you can have your note cards or whatever you would like to use on it. It's only a front and back. I think it's going to be kind of a nice, easier route. But then just make sure this is done on Friday. So if you get done with the quiz early tomorrow, you could also work on that to get that done and go from there. Questions for me? Look at that. I even came late to class and even got us done with some time to change. So do what?
Oh,
What did I do?
I was like, how late were you?
We're like 30 seconds late.
Well, the pledge had taken place. They came by and gave everyone donuts, and then kids went to lunch, and they came back, and then I finally got here. So, yeah, I was. You missed the lunch, yeah. I'm sorry. There might be some still in the hallway though if you need some. So I killed a black widow yesterday in the building.
Oh, wow.
Like I have not seen a black widow. Like I've seen black widows here, which are pretty small, and then you have the Arizona black widows that'll take your children away. I saw one that'll take your children away. I was like, oh my gosh,
School?
yeah, right out here on my doorway. Yeah. She had a snake in her classroom?
Yeah, snake came out of her classroom in East.
Oh.
And she just picked it up and took it outside.
There's a German, like the German teacher has a snake.
Oh, yeah,
Yeah, and
crazy.
lives there.
Yeah,